Welcome, geometry students, to week 5 of distance learning. This week we are going to finish up the unit on surface area and volume. Today is the last lesson, and it's going to be the surface area and volume of spheres. So let's go ahead and look at the surface area and volume of a sphere. I went ahead and wrote on the board the two formulas that are going to be critical for this lesson. So for each sphere or hemisphere that you see this week, the surface area is going to be 4 pi r squared. And then the volume is going to be 4 over 3 pi r cubed. Now I'm going to give you a chance to write that down, and as you're writing that down, I do want to talk about one more term for this week, and that's going to be the great circle. The great circle is the largest circle within a sphere. What this circle will tell you is the radius for the sphere. Now let's look at 3 examples to go with the surface area and volume of spheres. For each of these 3 examples, we're going to find the surface area and the volume of each sphere or hemisphere. Example 1. Example 1, we have a sphere and we have a radius in the sphere of 9 centimeters. We would plug 9 into the radius spot for both of our formulas to get the surface area and then the volume of this sphere. So for the surface area, it would be 4 pi times 9 squared. And then for the volume, it would be 4 over 3 pi times 9 to the 3rd power. Now you would plug that in. If you would like, you can plug it all the way in using 3.14 or the pi button. Or you could square 9 and multiply it by 4 and leave it in terms of pi. I'm going to write up both for each case. So for the surface area, you would get 324 pi centimeters squared or 1017.9 centimeters squared. For the volume of this sphere, you would get 972 pi centimeters cubed or 3053.6 centimeters cubed. Now example 2. Example 2. Example 2, we have a hemisphere. So for the volume, you simply take half. But for the surface area, what we're going to have to do is we will take half of the spherical surface area and then add the circle that creates the hemisphere. So taking half of the spherical surface area is just taking the dome, the top part of the sphere, and then add in pi r squared to get the flat bottom part of this hemisphere. So the surface area is 1/2, and then the regular surface area of the sphere, so 4 pi 6 squared, plus the area of the circle, which is pi 6 squared. So the surface area for example 2 would be 108 pi meters squared, or if you plugged in pi or the 3.14, you would get 339.3 meters squared. For the volume, you would just half the volume formula. So 1/2 times, and then our regular volume formula, 4/3 pi 6 to the third power. So the volume of this hemisphere is 144 pi meters cubed, or 452.4 meters cubed. Now example 3. For example 3, we have a sphere and they gave us the area of the great circle. Like mentioned earlier in this video, the area of the great circle will allow us to know what the radius is to use in our formulas. The area of the great circle is 36 pi feet squared. So if you think about the area of a circle, pi r squared. So pi r squared equals the pi 36 in this case. So our radius squared is 36. To solve this for the radius, you would take the square root of 36, and our radius is 6. Then we would use our surface area and volume formulas to plug in 6 and get both the surface area and the volume. So 4 pi 6 squared for the surface area, and 4/3 pi 6 cubed for the volume. And then you would plug those in. So for the surface area, you would get 144 pi feet squared, or 452.4 feet squared. And then for the volume, you would get 288 pi feet cubed, or 904.8 feet cubed. That finishes up the last example for this week. So what you're going to see now is the assignment posted below. There are 2 assignments for this week. One is from the textbook. And since we are finishing up the chapter, the other is a 2-page paper. I want you to write a 2-page paper on the real-life applications of volume formulas. So you'll be answering the question of, where will you use these volume formulas in real life? I want you to do some research and find different areas in which these formulas are used in real life. If you have any questions, please feel free to post, reply, chat, email, and I'll be glad to answer any of your questions. I'm going to be praying over each and every one of you this week, and I hope you have a great week, and I hope to see you guys soon.